Yes, sir, I started recording.
Started recording, right? Very good. So very good morning, my beloved students of underground coal mining methods. Welcome to our 11th lecture on 1st February. February is a very good month. It is not so or very cool. Comfortable must be. Now let me know whether you are able to see my screen. Then we will start our class. Okay. I hope you are able to see my screen. Is it fine?
No, sir.
You are able to see
No, sir.
screen, right?
No, sir.
Not it. अच्छा, यहाँ तो कुछ और दिखा रहे. Let me see. Share content. Okay. Now let me share the screen once again. Meanwhile, let me also say something without wasting much time. We are discussing about different factors which are responsible for selection of some suitable methods, right, of underground coal mining. So in that way, we discussed at least 3-4 factors yesterday, and other factors also we will discuss, so that if such conditions exist, which choice of method we may adopt are preferable based on previous experiences or literature. All those things we should know about it. So this is a purpose why we are discussing about various factors responsible for the choice of the method. Now let me know whether you are able to see the screen. Yes, no?
No, sir.
Not yet.
No, sir.
फिर भी कुछ प्रॉब्लम है क्या कनेक्टिविटी में? From my side, I did this. Sharing screen तो मैं कर रहा था, फिर भी नहीं आ रहा है. So let me once again. Now is it visible? Not yet. ये तो अभी शेयरिंग में शेयरिंग में दिखा रहा है. शेयरिंग में अभी आप स्क्रीन नहीं देख पा रहे हैं अभी?
नहीं सर, नहीं दिख रहा है.
स्क्रीन अभी तक नहीं दिख रहा है. नहीं, उसमें तो मुझे तो शेयरिंग करके तो दिखा रहा था. लेट अस सी. कंप्यूटर भी कभी कभी धोखा दे सकता है. डोंट वरी. वंस अगेन आई एम डूइंग. स्क्रीन अब देखिए. आर यू एबल टू सी?
नो सर.
नॉट इट. ये तो ऐसा तो नहीं होना चाहिए.
सर then rejoin sir please. Then
नहीं, ये तो प्रेजेंटिंग तो दिखा रहा है इधर मेरा फ्रेश स्क्रीन में.
हमको नहीं दिख रहा सर.
हाँ, अभी दिख रहा है आपको?
हमको नहीं दिख रहा सर.
ठीक है. डोंट वरी. आई एम विजिबल टू यू, राइट?
Yes sir. Yes sir. Yes sir.
So anyway, in between also I will try, but the screen sharing is having some problem, it seems. So we are discussing, my beloved students, on the factors affecting choice of mining methods. Already I have given you some of the references, especially in our Indian mining conditions, where Professor R.D. Singh and then Professor S.P. Mathur and Dr. T.N. Singh, these are some of the books where they concentrated more on Indian mining conditions. In that way, we discussed, I think, up to the thickness of the seam, how easy it is affecting, and also the gradient or dip of the seam, and then depth of the seam and shape of the deposits. Then there are structural and geological abnormalities which also are affecting which type of mining method, I mean which mining method may be more preferable. In that way, when you consider, there are so many structural features which are responsible, and mainly when you consider, there are so many times geological disturbances are there, geological discontinuities are there, and it is very simple to understand for us. Suppose if there are some type of intrusions in between, dikes in between, faults in between, and then washouts, etc. What happens is it is very difficult to go for a panel which is supposed to have at least 1 kilometer, 2 kilometer, 3 kilometer long, and then 200, 300 meter face length. Means you need a deposit of a regular shape of around 200 by 2 kilometer or 300 by 3 kilometer. That much size of the panel should be available if you want to go for long wall. Very simple to understand. So that is one of the issues. And there are so many mines, especially in Digwadi, there's a Jeria coal fields, where there was a seam number 14. Some of the examples I am giving you also available in some of the books or the references what I have provided to you, giving many Indian case studies. And since I also did some projects in those mines, I can give some more information on those things. So even in the same mine, some part of the mine that seam may be flat, or it may be regular deposit, where it can be 1 in 7, like in Digwadi number 14 zinc examples, right? And then in some other portion, now there is some type of a fault, right? In fact, that fault name in that mine also is called Bulambadri Rabiri Patadi. Okay. That fault, that name of the fault is also given based on the name and some geology and other places of that, where other part of it is almost becoming very steep, and then there people used on one side in seam mining for development, other things, and on the other side it is supposed to be used with only horizon mining for development and other things like that. And coming to the methods, as already I told you, many of the seams with the intrusions like dikes and even sills cause a lot of problems even for caving, and caving methods of mining also may be very difficult. And I also given you some examples where that caving is induced by blasting like that. And there are some situations like in the another issue is a gasiness and proneness to the spontaneous heating. So in that way, when you consider, there are so many seams generally based on gas content or the methane during the coolification process. So they are also named after different proportion of methane content, whether it is in the percentage wise or the in the mine where we are mining, right? So if you are producing this many tons of coal, then you are exposing some part of the coal where there is a possibility of that gas which is absorbed, right? Adsorbed, AD, absorption. There are processes which may release, and that also is taken to classify the seams into gassy degree number 1, degree 2, and degree 3 gassy mines. And here itself, let me know, have you gone through any of these details before in any semester about gassiness of any seams? Yes, no, please.
No, sir.
Very good. So then you note down, please. It will be useful in next subsequent semesters also for other subjects like ventilation, safety, mine fires and all, right? Where they are called as a degree 1, degree 2 and degree 3 gassy mines. When percentage of inflammable gas, mostly it is a methane, CH4, other ethylene and so many things may also be there. In general body of air, this is the way how it is classified. Degree 1 means less than 0.1% of this inflammable gas if it is there. That is called that mine as a degree 1. and greater than 0.1 in degree 2 and 3 cases, and rate of emission of this inflammable gas per ton of coal produced when you are producing suppose 1000 tons per day. When it is whatever the gas produced is less than 1 meter cube per ton of coal. If you are producing 1000 tons, so according to that you are blasting that much of coal or cutting that much of coal. So you are exposing that much of coal to atmosphere and gas is released, right? So in that way, if it is less than 1 meter cube per ton, you please note down these things. These are very, very important. Even till you are even when you retire from your profession as a chairman or CMD director, whatever, right? It is very important for any coal mining engineer, especially, right? So when it is less than 1 meter cube per ton of coal, that mines are called gassy number 1, and 1 to 10 meter cube, that range gassy number 2 mines, and then gassy 3 mines when it is greater than 10 meter cube of inflammable gas per ton of coal. And some of the examples I can say 90% of our seams, our coal seams, are coming under gassy number 1. Otherwise, there are some mines, some examples I can give you. You may also note down, especially when it comes to Godavari Valley coalfield, Singareni colonies, that mines, they are coming under gassy number 2, and where that requires more and more ventilation and problems of even explosion. So many may be there, right? So these are some examples just I told you. And then here coming to our choice of the method, when it is more gassy or spontaneous heating prone, that means what? When you are going for board and pillar, you have to open so many openings in the board and pillar, right? Like a checkboard, and then ventilation should go here, there, and so many places, right? So then it is giving more chances for spontaneous heating and poor ventilation at different places that builds up the heat. This is exothermic reaction. C plus O2 is called CO2, right? Carbon dioxide, or otherwise it can be 2C plus O2, that is a 2CO, that is a carbon monoxide, plus around 60, 80, whatever kilocalories. This is the equation. So where that leads to fires later if it is not properly ventilated, right? So now obviously it is better to go for longwall mining compared to board and pillar. There are more gassy. And one more thing is it is better to go for the slice mining or in thick seams or when it is gassy seams, right? In the descending order so that your gas may be collected on the top. It is not at the working pace, right? In the descending order. Otherwise, the best way is to go for stowing methods of mining so that you are not exposing that GOF or excavated area or coal for spontaneous heating or exposure to oxygen, right? So that is a better is going for stowing methods of mine. So in that way, coming to the next, meanwhile, also let me also try once again whether this is possible to have your sharing option once again. Let me try. If there is possibility, then it is better. Otherwise, don't worry, we will continue with that. I am trying once again sharing the content. OK. If you are able to see, it is fine. Otherwise, don't worry, I will continue to talk about this. Then characteristics of roof and floor, you may also note down like that. There are so many parameters. There are 15, 16 written by so many authors, right? Few at least I wanted to say, and many things we can discuss, of course, right? So when it is a characteristics of roof and floor, it is very simple to understand that in general, in our coal seams, which are of our sedimentary origin, there generally roof or floor is generally it is either sandstone, or if it is a thick coal seams, even in the floor also we may be leaving some of the coal, or we may be leaving coal in the floor or in the roof also, depending on which section you are interested, right? Acha. And then coming to spontaneous heating, whatever I said, even that equation also you note down, it may be useful in the chemistry formula also. C plus O2 is equal to CO2 plus 96 kilocalories. If it is giving carbon monoxide, that is very poisonous gas, carbon monoxide, even 0.001, 0.1%, that much itself is very, very serious, that causes even death also, right? 2C plus O2 is equal to CO plus 66 kilocalories, right? So in general, inferior grade coal is more prone for spontaneous heating, and these are the things just regarding that. When it comes to our next point, even now also let me know whether you are able to see the screen. Whenever you are in between, I am trying for that. Otherwise, don't worry. After that, then we will. Yes. So there can be some situations where floor may be very weak. And if this characteristics of the roof and floor also decides or gives some options of your most preferable methods. Very simple to understand. You just imagine a case where floor is very weak, so weak that even something like a clay or mud, something like that. And it is very, very difficult for you to go or use like LSD, trackless machines. It is very difficult because that may lead to the problem of even skidding of the machine itself. Okay, very simple to understand. And then when it comes to even in that way, if roof is very weak, right, then in board and pillar method, it is very, very difficult for us. The reason is in board and pillar, you have to expose so much of roof in the development stage itself. Then why to expose so much of roof in a bad roof condition? Very simple. So better not to go for board and pillar. This is the way how we have to think about it, right? Because there are so many roads and all to be maintained. In that case, it is better to go by longwall mining. That is the way how we have to decide. And then sometimes there may be very strong roofs, very competent, like even sill, igneous intrusions, right? And where it cannot cave, then you should not go for, right? Caving methods of mining. Already we have seen the music of this induced caving and difficulties in all those things, especially in southeastern coalfields. Examples I have given you, whether it is a Charcha mine or Rajendra mine and all those things, right? Then in that case, whether it is not too weak or not too strong, in that way, weak or floor roof, right? And in that case, what you are going to do in many cases, what we do is we go for even hydraulic mining also, right? So this is the way how we decide. In very weak roof condition, better not to go for board and pillar because you are going to face a lot of problem in the development and you have to maintain the development working for a long time, even throughout the life of the mine. Okay, so it is better to go for longwall mining. This is the way how we have to decide. And in between, I have been trying for sharing it and there was some problem, but at least you are able to hear the voice. Let me at least continue with this. Then there are so many other situations which are supposed to be considered, right? Something like even hydrogeological conditions, as I was showing you yesterday also before, different factors, right? Where you know very well, I used to tell you Kanti series, right? So they are the highly water charged strata that we have, especially in when you see in the central part of India, right? Where that means when you are even making holes in the sandstone roof, so that water will be oozing out, right? So like that. And now suppose if you have some type of clay in that, what will happen? That clay, when it is dry, no problem, but when it is wet, then that is going to cause a lot of problems. And then it is better to not to go for such methods to expose the roof or any condition in such a way that you are exposing for a long time, right? So in that way, also our board and pillar, where even when you see, it is better to go for the stowing or backfilling so that you are not disturbing the roof or other conditions where it is water charged. Suppose you are going for caving and the water is there and water is continuously oozing out to that or getting connected to other workings, and then all many problems like that. And some of the examples I am giving you in that situations, people also worked where even under the sea, even under the water ponds, right? Some type of nala and so many things. With even I have given you an example of working under Damodar River, even in Amlabad Colliery in 1980s, I told you in investigations where we used to have limited width of the workings, at the same time stowing also, and then without stowing also we work. And some other example, that was a BCCL Amlabad, and another example without stowing, Khani mine, right? That Jai Balaji Padmavati, right? That mines in that is in Kottagudam collieries, right? Ellandu, I mean not Ellandu, Singareni collieries, where we were doing 60-meter width of the longwall panel. In that way, that is a non-effective width where that will not affect the overlying workings. So that overlying, even if there is a nala, even if there is some pond, right? In that case also, you can do working with new method, I mean non-effective width of even something like a short wall mining, right? This is the way how we will be designing the methods considering hydrogeological conditions. And there are so many examples given even in that books, in somewhere something like Velenje mine in Yugoslavia, right? So they did even under different water bodies, as I have given some examples of India, where we designed some of the methods for protection of the surface feature with water bodies and all. Same thing in GDK 5 incline. I'm giving you so many examples to you, my beloved student. And even now we are doing some investigation on GDK 5, 2 and 2A. You please note down somewhere. This issue also I will be discussing with you. GDK 2, GDK 2A and GDK 5 incline. 5 incline under Jangaon tank, we designed the methods where to protect that waterlogged, I mean overlying pond, and still we are working under that somewhere, even with stowing and without stowing, with designing different methods. And now we are converting now we are doing another investigations at present. Even yesterday I sent a report to them in Ramagundam area 1, where Mr. Narayan is a area general manager, right? So we have sent the reports to Satyanarayana agent and all those people, right? So in this way, in some countries, even they design the methods where C is there under that, so that the strain should not be developed more than 2 mm, 3 mm per meter. Strain, of course, does not have the dimension, but in mining, we use this terminology because that much strain causes some type of cracks. And you should design the method in such a way that the strain should not be more than 1 mm, 2 mm, 3 mm. It is there even in the Indian mining law or the regulations and circulars. You can see DGMS circular and all. And this is the way how we are supposed to deal with. And coming to other parameters, there are so many other parameters which I have not noted in this. And since it is also being recorded, you can see it later also. Don't worry if it is not being projected because of some connectivity problem. Even there are some other parameters like as already given about the gas content and other things, characteristics of roof and floor, geological discontinuities already we discussed, and even cleavages and dirt bands, right? So that also will give you some option. If it is highly cleated, then it is better. Even you need not have so much of effort for blasting and other things. Even plows can be used, and that is just to drag that highly cleated, already pulverized coal to extract, right? So there are the ways to decide which type of mechanization and other things required. And then sometimes if there are some dirt bands and all, that poses a problem of stress concentrations. Already I have given you, I don't know, yesterday, stress management is not required. Stress relieving is more required. Already I told you, and I have given you in the WhatsApp group also. One of our senior with whom I was there in Usman University studying together for about 1 year, right? He will be joining here as a director shortly in NIT Rourkela, Professor Uma Maheshwar Rao, right? So in that way, when there are some dirt bands in the seams, right, that causes stress concentration, and that may lead to some type of outburst, even bumps, and so many things will happen. So we should decide the system of mining and distinguishing this high stress zones and then orientation, right? Like that. That is even cleavage directions. Mechanical properties of coal also determine, right? Mechanical properties, because in that I have not written all the factors here, but these are all some of the other factors like mechanical properties of the coal, wear, strength of that and hardness and abrasivity, all these will be affecting in the selection of the machinery also when you are going for mechanized mining. And then in that way, all those other issues, of course, strike of the seam gradient, all these things we discussed, and a little bit more just to continue further. After 5 minutes, I will take a break, right? Completing all these parameters. Then already availability of the machines, right? You can see in the factors affecting some technical and economical factors also. For example, technological development and availability of the machines, economic value of the coal, abundance and short supply of that materials, whatever coal and other things. Depending on that, you have to decide. Even sometimes we need not or we may not be able to forego or get less recovery by board and pillar, right? Where if it is that coal is a good quality coal, right? Of course, anthracite coal is not, excuse me, available in abundance, but all are bituminous coal. What we are getting it in of different grade quality, different rank. Generally, it was given as A, B, C, D, E, F, something like that. And nowadays it is reclassified into G1, G2, G3, G14, something like that, based on the calorific value of that coal. All this information you may note down. As a coal mining engineer, you should know about it, right? Then availability of the machines. Now you can see availability of even the technical skills and experience prevailing in that particular country. All this also affects us. And here I can give many examples and number based on our experiences. But coming to availability of the machines, how to select which methods may be better. So in general, since we wanted more and more, even the demand of coal, nowadays, I hope who can respond to me? What is the coal that we produced in the last year? Anybody? Because I have circulated all that coal directory, I think last week to everybody through WhatsApp and like that coal directory of India. Who can say? Anybody? Or let me know whether my voice is audible or not.
Yes, sir, audible.
Very good. So everybody must have seen that coal directory of India I shared with everybody. I mean in the group also. Right there, what is the production, then productivity, and so many things are there. Anybody want to say how much coal we produced last year? I mean 2021. Even in that some information is there on the latest information of how much coal we are producing. Okay, it's all right. Don't worry. In fact, we had a demand of 1 billion ton, 1,000 million tons of coal. We are unable to produce so much because of whatever the limitations, right? Then in that we are producing only around 700 or like that, 750, something like that. When you put together with Singareni Collieries and then private companies, Coal India, everything is given in that, where we are even importing the coal also. So tomorrow I wish that, tomorrow means in the next subsequent classes, I wish that you please go through that material also. This is the reason why I share the information as soon as I get it through some of my friends, maybe from the ministry, from different research organization, or from the companies, maybe CMDs, maybe so many people, directors and other people who were working with me like that. So immediately I used to share with you people and try to go through that. And that time we can discuss a little bit more on the total coal directory of India. Okay, right. Of course, that total statistics are not required for us, but at least you should have some idea that yes, how much you are producing and how much you are importing, what quality, and then by underground mining, by open cast mining, if it is by public sector undertaking, and what is the availability of the skills or mechanization. So many things will be available to us through latest information. Okay, now coming to our availability of the machines. Now initially when there was no mechanization at all. Now it was very simple, the technological development. I am talking about the point number one. Of course, it is not visible to you, but it is recorded. So when you are seeing that, that will be, you can also find out without any problem. And here, starting with only blasting with the explosive without even delay detonator, with some cut there. I'm giving a chronology like that, right? Where before that, it was even ladies also used to work and then haul the coal and even mules were used, horses or donkeys, whatever, right? So for there are so many history when you see the mining, all this, the technological development, how it took place. In that way, for mining, this invention of explosive or blasting mechanism itself is a great boon for breaking the rock. Then thereafter we stopped pig mine. Then technological development there is blasting, but that blasting without any delay detonator, right? Whatever Nobel and all people develop. Then later delay detonators are another development where we need not go for a cutting. I mean making a preface and then using delay detonators, solid blasting and all. And later, of course, continuous miners and cutting machines. That is a latest development, whether it is a board and pillar or long wall, whatever the mechanization, whether it is a tunneling and other things also. So technological developments took place like this, where we were even now, I should say, when it is a continuous miner, we are getting around 2,500 to 3,000 tons per the machine and that panel, whatever. Otherwise, if it is SDL, around 150, 100 to 150, or if it is LSD, 150 to 200, all these things you should know about it. Then if it is a long wall, we started in 1980s, where we used to get even 2,000, 2,500 is a great production at that time. I mean, 30 years back or 40 years back when I was like you, right? We were getting from GDK7 incline, where first time we introduced in Singareni, otherwise in Munadi and other places in Bharat coking coal and other places, or whatever, longwall mining introduced by Chinese set, Anderson, Strathclyde from different countries. Then it was around 2,000, 2,500 in 1980s. Okay, and later now we are going even for around 2.85 million tons. You please note down, which requires around 10 to 12,000 tons per day to be produced, right? And even in Australia and other countries, we have more than even 3 million tons of coal, which is something like open cast production we can get from underground, right? So in that way, how this in that way we already seen thick and steep seams hydraulic mining with hydraulic monitors with high pressure hydraulic jets. We also tried, but we failed in 1980s in Gopalichak BCCL mines, right? And in very deep mines, that is the reason why in the technological development future is, you please note down, bold, italic, underline, whatever, right? Red color. Underground gasification only will be the choice for us when you are going deeper and deeper horizons, even beyond 1 kilometer or 1.5 kilometer, like that. And then even in the very deep or the steep and all those conditions, right? So this is a way how we have these technological developments. And then when it comes to even economic value of the coal and people, of course, it is more suitable for open cast mining, where people were mining in UK or in different places, South Wales, or in some other coal fields. Even the vertical ratio, when you consider something like a stripping ratio, overburden to this, even 50, even 63, like that, people say that is more about the open cast mine. But coming to economic value and then selecting a mining method, so we can say in short, as in a layman's terminology, where we should, if it is a high grade coal, high quality, then it is better to go for high recovery with due consideration to the conservation. And it is better to go for even backfilling method or stowing method, stowing with sand or otherwise with fly ash. Nowadays, fly ash is a failure. We have done a lot of experiment with CFARM, Center for Fly Ash and Research Management, and some of our colleagues, CN Ghosh and others, chief scientists in CMRS, they also made some attempts, some were failures, and later we were able to do pond ash as a backfilling, and that is successful in that way. So where you can use that type of methods, not only just to protect surface features, but to get more percentage recovery. All those things we have to plan for it. Then, of course, abundancy of and then short supply. Based on that, you will decide which type of mines, which type of quality of the coal, where you can forego some part of it. I mean, conservation point of view, even less recovery in poor grade coal or quality of mineral, whatever, in any mining situation is affordable, but high grade ore or high quality coal, it is not affordable or it will become uneconomic for us when you leave the coal, and conservation there is very, very important when the quality is better, right? Then in that way, what is the methods? Then go for high recovery, that is a long wall mining, or even backfilling, packing with some other material. So many things we can think of it. And one more latest trend is even you can replace the pillar with some type of cement or some type of backfilling, and then you work the other part of the mineral also. And that is also being done even nowadays. Now some of my PhD scholars in Vedanta, our Ella Murugan and then Deepak, our assistant controller IBM, all these people are also doing their PhD on these issues. Okay, so many things we will discuss any other time. And then that is the reason why abundancy and short supply also determines which type of methods you can use, and then availability of the technical skill. I can give a very good examples where the skill familiarity of the methods is very, very important when you are suggesting some methods in the mines. And there otherwise you need to have training, and for training you please note down somewhere where we have sent many mining engineers, Coal India or whether it is Singareni College, they used to call as a Colombo plan, where when longwall mining we introduced our board and pillar to France and other places, we used to send them so that they will get trained in that and then come and then supervise. And then we used to even keep for 1 year, 2 years, those people from France and other countries, Germany and other countries, for importing these technologies of sub-level caving or longwall mining, even from China, our good friends, of course, Pakistan, China, everybody are our good friends, we love them, right? So we also used to have them here 1, 2 years and then train our people. That is the way how availability of technical skill also helps or determines or is a factor in selecting the method, right? And experiences prevailing in the country. Now, we are more familiar with board and pillar method, and this is one of the reason when we were going for alternative to blasting gallery method when it was a failure in 1980s. I mean 86 to 88, that period 89, when I was also there in CSIR labs at that time, associated with those trials, international collaborative trials. Then we decided to develop indigenous method with a small development, a small modification without changing for much, and which is equivalent to blasting gallery method we designed in Chirimiri method, NCPH, Chirimiri caving method also it is called as a method of cable bolting for thick seam mining. And you can also see in so many books, and that also was accepted after 4 experimental trials when you design any methods. So this much of effort is required. All those things we will discuss. And I need more and more innovative approaches from you, my beloved students of underground coal mining methods to suit this complex geomining conditions that we are entering into in future, because our forefathers are long back. They have developed, extracted so many coal seams and deposits which were with good geological condition, which they thought it is very bad or geologically disturbed. They left it for us we left it for you, and you may leave. And all that needed is you are more smarter than us than to design innovative mining methods, and that's what is required. And there you should consider experiences prevailing in the country. The fifth point, what I have written here in the factors affecting choice of mining methods under technical and economical factors, you may not be able to see because of this technical problem or connectivity, but since it is recorded, you can see that. Then in that way, factors affecting even division of mine into blocks, development, all those things we will discuss later. And then we enter into the in-seam development, horizon mining, then development into all these, and then Boden pillar, opening out the districts, pillar development, gallery, pillar size and width of the barrier, panel size, extraction, all those things we will discuss with so many case studies of the latest. Since today we are unable to show you that screen, I am not showing. Otherwise, I got for you this continuous miner district related, how continuous miner is working, and then to compatible method of even supporting with resin bolting, mechanized resin bolting, all that clippings, everything I got it for you. But today I'm unable to show because we are unable to show the screen to you. So don't worry, mining engineers have solutions with lot of safety factor, and safety factor 10 also we work, and very well, already we discussed before, and about that. For winding, man winding, we use safety factor 10. Okay, now with this, I want to stop here, and your doubts, now it is 8:56. Let me have any of your doubts, and then summary. This is the way how, still I am, once let me show you whether it is possible. No, but once there was a problem in between, it seems. So again, I am starting recording. Don't worry.
Good morning, sir. Sir,
Yes.
I am.
Sir, recording is going on.
बताइए.
Sir, I am Amitanandan Oja. I have a doubt that about absorption of that gases. Means in
Right.
which surface that gas gets absorbed, and how does it affect the means mining environment if it get absorbed in any of the surface?
Very good. It is a very good point. So here, when there is a qualification process, right? Acha, who can tell about any other doubts put together? I will answer. That is more better. Any other doubts?
Sir, I'm
Yes.
Suryakant, sir. I have a doubt that,
Surya.
sir, how can we use blasting method in the coal mine, sir? Because like
How
we
can we use
produce
blasting?
Yes, sir.
Acha, that means you are interested to know about the blasting, how it is done, or a blasting gallery method or something like that, Dixie mining.
The blasting in coal seam
How
can
blasting
also
is done?
create. Yes, sir.
TK, it's okay. So now coming to number one, about this absorption or adsorption, and then in the qualification process, what happens? This coal is formed the plant materials, that much everybody knows, right? Am I right? Coal is formed, right, by qualification, that is the plants and other materials, carbonaceous materials, right? And that also is by two processes. One is a in situ theory and another is a drift theory. Whatever may be the theory, but when that plant materials are there, subjected to high stresses, right, and then high temperatures, right, over millions of years, it is not taken place just in 100 years or 10 years or within a day. Even now we construct within 21 days a very good house. Our IIT Madras, they have done a startup. Some of you must have seen, which costs around 5.51 for a double bedroom, like a house. Okay. So it cannot be made, or that coal or the deposits are over millions of years. Okay. That is the reason why it is depletable. So once it is over, then of course, don't worry. We have a lot of deposits in India. We need not worry for 100 of years. Okay, 100 years at least. Okay, so in the qualification process, when that carbon, right, of the content in that, along with so many other materials, okay, then methane is also there, and methane is a CH4, everybody knows, hydrogen and then carbon, okay, cycle, methane, ethylene, and so many things like that, which you read in the hydrocarbons in your +2 also, okay, or 10th class nowadays. There, that part of that is absorbed in the molecules and then in the coal itself, right? So when you are just breaking that coal or exposing that to atmosphere, again, that gas, whatever is there, that will come out, very simple. Okay, and that is what is inflammable. And methane, there I have not told at that time, you please note down in now. Methane, if it is around 5 to 15, to be very precise, 5.4 to some 15 point, 14 point something, 5 to 15, that range is highly explosible, and explosible limit that is there in that percentage. The reasons and all very simple to understand, but need not discuss at present, right? If we have doubt, anyway, we can discuss. But in mine fights, we have a separate semester in mine ventilation, and then mine rescue and hazards, all those things also. In that courses, you will be learning more and more in details. But this is highly explosible within that range of a chemical reaction with that much a percentage of methane in the atmosphere or in the underground air. Okay, so now coming to the next, Surya, blasting related. Now, anyway, we will be discussing about so many blasting designs and all, but in general, you please note down somewhere where your gallery is around, suppose this is your roof, and then this is your gallery of 4 meter width by 3 meter height. Okay, and then to blast this, okay, then we need to have around 11 to 12 holes, and we will be using a wedge cut pattern, whatever it is, and there are some regulations, so many things for that, right? I can give you so many examples of that, but in short, for a layman, anybody to understand, here what we do is we make the holes, and then with explosive, it should not be more than 1 kg in each hole, and all that regulations are there, and circulars are there. And then after blasting, you may be getting about 1.5 meter pull, right? So 1.8 meter long. Then when it is 1.5 meter by 4 meter by 3 meter height, 3 meter, 4 meter by 1.5. So how much of coal you will be getting, right? So that much, around maybe 20 tons of coal you will get per blast once you blast it. Okay, then that is the reason why we are also estimating what is the powder factor. This much of explosive we used, right? So we are using 10 kg of explosive or 12 kg of explosive, and then getting around 20 tons. That means this much ton, around 2 tons per kg of explosive, or 1.5 ton per kg of explosive. This is what is a powder factor, and then detonator factor. This is the way how we all decide about the performance of blasting and all those things. Is it fine, Surya and other for today?
Yes, sir.
Acha, now who are ready to summarize today's, because some of the points you must have definitely noted it, and partly it was recorded, that recorded versions I keep, but there were some problems, it seems, of net connectivity or other things, but at least still you are able to be connected and in connection. इसलिए मैं बीच-बीच में फिर start stop ये सबका try कर रहा था मैं recording and then sharing screen also. It was not happening, but don't worry, as long as we are able to get connected. Now who is going to summarize in short?
Yes, sir, I can do, sir.
Yes, please.
Suryakant.
आगे बढ़िए, आपका नाम
Sir, we
बताइए,
start-
आगे बढ़िए.
Yes, sir. Sir, Suryakant.
Surya, right.
Sir, yes, sir. We started with some factors that the geological disturbance, like we take example of Zoria coalfield, that seam number 14 has a gradient of 1 in 7. Then we discuss some examples like Bulambad, Giri Patil, and then you said, sir, like even in the same mine, the seam may be flat, and in same on other part of that seam, it might be inclined or any fault can come in that. Then in the next factor, we discuss some of the gaseous conditions. Then we discuss some like gaseous degree 1, degree 2, degree 3. Then how they are classified like below 1 meter cube, 1 meter cube per ton. We discuss that is gaseous number 1. Then uh, in between 1 to 10 it is gaseous number 2, and above 10 meter cube it is gas number 3. Then you give an example of Sinagiri, Godavari River Valley mine that has a gas number 3. Then
Very
in
good.
the combustion, spontaneous combustion, we discussed that reaction C plus O2 equals to CO2 with 96 kilocalorie of energy. Similarly, 2C plus O2 CO with 66 kilocalorie, which is for CO gas, which is highly dangerous for health. Then the best,
That's
then
nice. Good.
then after that we discuss on the best ways in the gases areas like stowing method of extractions. Then after that we discuss the roof structures and floors characteristics of roof and floor. That roof might be of sandstone or it might be of coal seam as much we require. Then we discuss if the roof is a roof or the floor is of clay material, then it can make skidding the machineries. Then if the roof is weak, we shouldn't go for board and pillar, we may use long wall. Then if the roof is not weak and as well as not strong, we can go for hydraulic mining. Then we
Very good.
discuss some of the hydrological conditions. Then you give an example of which stowing BCCL Amalabad mine. Then some of the example GTK 2, 2A, 5 incline methods designed to protect the waters from the from the above lying areas. Then cleavage and dart we have discussed, and selection of mining like stake of the mining gradient we discussed. Then factors affecting the economic value. You give some new names like G1, G2, G3, G14, the classifications of the coal grade.
Very good. Very good.
Then we discuss the availability of machines. Like as we require more and more, and demands is also like 1,000 billion tons. We are designing more and more, but now it's about 700 billion tons. As well as we are importing from some other countries also.
Right.
Then we discuss some of the machineries like the history of the mine machineries. We started with only blasting without any delay detonator with ashes used. And after that, we use some peak mining methods. Then we introduced delay detonator. After that, continuous miner, where the extractions goes high, and we used LSDs, etc. Then we in that after that we discuss some of the factors like underground gasifications, where we go deeper and deeper to the mine. Then uh, at near the last we discuss some of the technical skills where Colombo plans is introduced, where they from other countries the students come and take training. And at last, mm, you given some example of Chirimiri mining where you change a blasting gallery extraction, gallery, and you extracted the mineral coal, sir. Yes, sir.
So there was a little problem in sharing the screen and all. Don't worry. Even that recording also in between was on and off. TK, don't worry for that. We will discuss further in the next subsequent classes. All the best. Now we'll take care of Omicron COVID-19. Last में क्या बोलना है जी?
Jai Hind, sir.
Jai Hind,
Jai
Jai
Bharat,
Bharat.
Jai Hind.
Take care.
जय
Take care
जवाहर
of
सर.
COVID-19. Right. I'm closing it. Stopping recording is not